In segment 2, we continue our discussion of the activity reasoning using Unifix cubes. In video segment 1, we gave one example of a makes more task and one example of a sells some task. And we indicated that the ways children use the Unifix cubes to act out the stories and figure out how many candies there are now differ substantially. Further, we showed how these differences reveal the wide range of conceptual understandings of tens and ones children have within any class at any given time. Children make advances as they engage in the tasks of these types repeatedly, and as they participate in class discussions where they listen to and attempt to make sense of others' thinking and reasoning, and as they engage in partner work where they solve tasks of these same types. We see several solution approaches that emerge as typical. Let's take a look at one more example of each type of task, a makes more task and a sells some task, to see what these typical approaches are. We begin with a sells some example. Hope begins by getting out 5 rolls and 3 pieces which she has snapped together. To show that Mrs. Wright sold 15 candies, Hope takes away 1 roll, the group of 3 pieces she has, and breaks 2 pieces off of another roll. This leaves her with 3 rolls and a group of 8 pieces snapped together. Her final result looks like this, which she easily knew was 38 candies. Lucas started the same way as Hope. He got out 5 rolls and a group of 3 candies, which he had snapped together. To show that Mrs. Wright sold 15 candies, Lucas took away 1 roll and broke 5 pieces off of another roll. This left him with 3 rolls, a group of 5 pieces snapped together, and the initial group of 3. His final result looks like this. He easily recognized this as 38 candies. In the discussion of this task, the teacher will ensure that children make sense of Hope's solution and of Lucas's solution. Questions such as, Amelia, what do you understand about how Hope figured this out? Or how Lucas figured this out? Are useful because such questions will get others involved in the conversation. These others describe the solutions in their own words or ask questions if they want further clarification. And that brings even more children into the conversation as still others explain what they do or do not understand. Another useful question is this. Are Hope's way and Lucas's way of figuring this out the same or different? How are they the same or different? This question is at a different level because it is asking students to think about each solution as an entity, a thing in and of itself, and compare it to another. For example, in the discussion of this question, students might talk about how both Hope and Lucas started off with 5 rolls and 3 pieces, and they will notice that both started by taking away a roll for the 10 in the 15. As an aside, children almost always take away the 10s first. It is at that point that the 2 solutions differ. Hope took away the 5 by using the 3 pieces that were there initially, and then 2 more pieces from another roll. Lucas took away the 5 that he needed to give to the customer from 1 roll, leaving 5 from that roll and the 3 pieces that were initially there. As this part of the discussion progresses, the teacher will surely use her Unifix cubes to demonstrate both ways of taking away the 15 for the class to see. One of the challenges of this type of discussion is that demonstrating how the cubes were taken away is a dynamic process, so that as soon as the demonstration is finished, there is no record that shows the difference in the 2 approaches, except that in this case, the final configuration of cubes the 2 children had differ. As children become familiar with these types of solutions over time, the teacher might want to focus more attention on how the solutions differ. To do so, it is useful to have some way to keep a record of the solutions that the teachers can refer to that help to clarify the difference. The question is, how do you make a static record of action that is dynamic? We have found that drawings are useful for this purpose. Here we show drawings that the teacher might use beginning after several days of working with tasks like this. These drawings are a type of notation. The teacher will talk through this notation as she writes it. First, she will explain that rather than draw a picture of a roll, she will draw a line to represent a roll. She will talk through Hope's solution as she draws 5 lines to represent the 5 rolls and then draws the 3 pieces. She will then draw an X through one roll to indicate that Hope sold that roll to the customer. And she will draw an X through each of the 3 pieces to indicate that Hope gave those to the customer. Next, the teacher will draw a small horizontal line through the roll on the right and write the numerals 2 and 8 next to it. The X next to the 2 indicates that Hope took 2 pieces from that roll to give to the customer. She is left with 3 rolls and 8 pieces. Likewise, the teacher will talk through Lucas's solution as she draws 5 lines to represent the 5 rolls and then the 3 pieces. For Lucas's solution, she shows that he used 5 pieces from a roll to give to the customer. He is left with 3 rolls, 5 from the roll he's unpacked, and the original 3 pieces. There are 38 candies left. It is possible to tell by looking at the completed drawings how Hope and Lucas solved this task. The drawings are records of their solution approaches. They show how the approaches differ. In our experience, teachers find this notation easy to use and students quickly understand it as well. The beauty of this notation is that the teacher does not show the 10 individual pieces in the roll that is used to complete the number of pieces given to the customer, but instead uses numerals to show the number of pieces from that roll that were sold. In this way, the notation not only serves the function of being a record of the solution, it also shifts the focus to thinking quantitatively rather than in terms of individual pieces that would otherwise have to be counted by ones. As we said earlier, we suggest that the teacher not use notation on the first day of using tasks of this type, but that she begins to use it after several days. By then, children will already have had time to develop meaningful ways of solving tasks of this type and will be able to make sense of the notation. As our examples show, this type of notation is especially useful when comparing solutions to take note of similarities and differences. Now let's take a look at a makes more task. Here you see the task that is posed. There are 2 typical solutions for tasks of this type. We will illustrate them by showing how Samantha and Reginald used their cubes to solve the task. Samantha got out 36 candies by getting out 3 rolls and 6 pieces, which she left snapped together. Next, Samantha got out 17 as follows. She got out 1 roll and broke a group of 3 off of another roll to have a group of 7 snapped together. Now that she had 36 and 17, she combined them like this. She took 4 of the 7 and snapped them together with the 6 to create another roll. Her final result looked like this, which she easily knew was 53 candies. Reginald started the same way Samantha did. He got out 36 candies by getting out 3 rolls and 6 pieces, which he left snapped together. Next, he got out 17 by getting out 1 roll and breaking a group of 3 off of another roll to have a group of 7 snapped together. He combined the 36 and the 17 like this. He took 3 of the 6 and combined them together with the 7 to create another roll. His final result looked like this, which he easily recognized as 53. As with the cell-sum example we have just discussed, the class discussion of the makes more task will surely involve the teacher using her own cubes to demonstrate the solution approach each child used. And as we noted with the prior example, the teacher's demonstrations are dynamic. and once completed, there is no record to show what happened. In fact, in this case, the final configurations of cubes that result from the solution approaches are identical. It is impossible to tell just by looking at the final configuration of cubes these children had that they packed up the candies to create another roll in different ways. Both approaches resulted in 5 rolls and 3 pieces. Once again, we suggest that after several days of using tasks like this one, the teacher begins to use notation to record how the tasks were solved. Here we show notation that teachers have used successfully for this purpose. These drawings show the initial 3 rolls and 6 pieces, and then the roll and 7 pieces that represent how many more candies were made. The loop around the pieces shows how each child thought of combining pieces to pack up another roll. Samantha used 6 of the original pieces along with 4 of the additional candies that were made, while Reginald used all 7 of the additional candies that were made along with 3 of the initial 6 pieces to pack into another roll. In both cases, there are now 5 rolls and 3 pieces for 53 candies. Notice that in both drawings, 4 rolls show up as lines, while the 5th roll is shown with a loop around the candies that are packed to make the 5th roll. Now, as an aside, we note that this approach of drawing a loop around candies to show that they make up a roll is similar to what children did in the circling candies activity in part 1 of this sequence. We want to make one additional comment here. In our discussion of Samantha's and Reginald's solutions, we remarked that both children had cubes that represented the pieces in the initial 36 and the 17 more that were made snapped together rather than broken apart. But here we show them as individual circles. This is important in the notation the teacher shows because children are looking at the teacher's notation from a distance. So it is important that they can clearly see how many pieces there are. For this reason, it is also important to show these amounts in easily recognizable patterns. Here we show 6 as 2 columns of 3 and 7 as 1 column of 4 and another of 3. We have one additional note of caution about this notation for the makes more tasks. It is important to not draw an initial line, a roll, to show that another roll was made, because then there is confusion about what is represented by the loop and that additional line. Rather, leave the newly packed roll shown by the looped group of candies. In our experience, teachers that draw an additional line inevitably introduce confusion. This concludes video segment 2. Video segment 3 will conclude the discussion of the instructional activities that comprise part 2 of the coordinating units sequence. It also includes a suggested timeline.